Hey guys, today we are going to be discussing application of derivatives. This means we are going past deriving and using derivatives to describe and solve graphs. Applying derivatives to graphs involves solving for a few different things: extrema, critical points, where the function is increasing or decreasing, and the function's concavity, meaning where it is concave up or concave down. So let's take a look at the function f of x equals 3x to the fourth plus 2x cubed plus x squared plus 3x. Taking the first derivative allows us to see where the function is increasing and decreasing. The second derivative shows us where the original function is concave up or down. If we look more in depth, we can use the first derivative of a function to find the maximums and minimums, or the relative extrema, and where the function is increasing or decreasing. Relative extrema occur where the derivative of the function is equal to 0 or undefined. These x values are called critical points. To find these points, we set the first derivative of the function equal to 0 and solve for x. Let's apply this to x squared plus 3 and its derivative. Setting the derivative of x squared plus 3 equal to 0 shows us that our critical point is at x equals 0. Therefore, our derivative crosses the x-axis at 0 and our minimum occurs at 0. To look at where functions are increasing or decreasing, we then perform the first derivative test. First, find the derivative. Then, set the derivative equal to 0 and solve for x. Then create a number line of f prime with your solutions. Plug values between the solutions into the derivative. The graph of f is increasing on positive intervals and decreasing on negative intervals. We use the second derivative test to solve for concavity. So, take the derivative twice. Then, find the solutions of the second derivative, called possible points of inflection. Just like before, create a number line with the solutions of the second derivative. Positive intervals are where f of x is concave up, while negative intervals are where f of x is concave down. We can apply what we now know when looking at the graph of a derivative, which is what you will usually be doing in calculus. If we are looking at f prime of x, we know that f of x is increasing anywhere where the derivative is positive or above the x-axis. Therefore, f of x is decreasing anywhere where f of x is negative or below the x-axis. We can find maximums where f prime of x changes from above to below the x-axis, or in other words, from increasing to decreasing. Minimums are where f prime of x changes from below to above the x-axis. F of x is concave up when f prime of x is increasing, and concave down when f prime of x is decreasing. Therefore, the points of inflection then occur at maximums and minimums of f prime of x. Mean value and Rolle's theorem go along with application of derivatives. Mean value theorem says that if a function is continuous and differentiable on an interval, there exists a value c, whose derivative equals the average rate of change on the interval. For example, if we have the function f of x equals square root of x on the interval 1 to 4, we know that the function is continuous and differentiable. Therefore, we can find the average rate of change, or c, by setting the derivative of the function equal to f of 4 minus f of 1 over 4 minus 1. When we solve for x, we are able to find c. Rolle's theorem tells us that if a function is continuous and differentiable on an interval a to b, and f of a equals f of b, then there is a value c whose derivative is equal to 0. For example, this polynomial function has the same y value for f of 0 and f of 4. So, we know that the derivative is equal to 0 at some point on the interval, and we can solve for that c value. Let's highlight the differences between mean value and Rolle's. Mean value says that there is a value c that is the average rate of change of the function on the interval. Meanwhile, Rolle's says that if f of a is equal to f of b on the interval a to b, then there is a value c whose derivative is equal to 0. Lastly, let's talk about optimization. These are usually word problems asking you to find the maximum area of a fenced-in garden or something like that. First, create your optimization statement or your goal for the problem. Like here, you would be maximizing area. Then the area would be the equation you have to derive. Then you solve for the variables and double check to make sure that these are actually your maximums and minimums. Applying derivatives includes a variety of different topics. We covered how to do the first and second derivative tests, as well as how to evaluate the graphs of derivatives. We also discussed mean value theorem and Rolle's theorem and how to do optimization problems. Thanks for listening and happy calculusing!